Hey guys, it's Rob. I'm making another video here. This one I think is going to be different because I want to just show you some common sense stuff about our planet that anybody can see and figure out on their own. They don't need somebody with a PhD to explain it to them. But what I want to point out here is that on our planet I keep seeing reoccurring patterns of these islands right here, or this texture. You see how you have these dots in order, and I wanted to kind of do a little investigation on that, because you got to remember here, this is a subduction zone. They claim that this plate is moving this way and it's going underneath this and being destroyed in the Earth's mantle by the heat. Well, I just want to show you something. If you look at the texture here on the ocean bottom, you can see that it goes this way, and you can see that it hits here. There's a reason that happens like that, and that's what I want to investigate right now. You see it hits here, but then if you look, it goes underneath and it comes back out, and the islands lead here to this area. And this is where I started noticing that how these are spaced out evenly, and they look a lot like this. But you'll notice this also goes, well, the underneath looks like it goes this way. So you'll notice that again, here's the spacing. Okay, you see how these islands here are spaced a certain distance apart from one another. Well, I've noticed, in my research of the planet's surface features, I've noticed that I keep seeing that same spacing, reoccurring theme of it all over the planet. And that's what I see, like these islands too, same thing. This has to do with movement. Has to be, that's why there's an order to the the features here, because there's a certain rate of speed that it's following, and this is being dropped out at, I guess. I don't know how else to explain that, but see, and then yeah, you can see that here we go with the spacing again with these lines, and it all seems to stop right here, and it's either submerged or something underneath the features here, the smoothed out features, like as if you took sandpaper and filed it down, or something, and smoothed it out, or wiped it clean. And here we have that spacing again. And let's do some matching here and see what happens. But before I do that, check out that spacing here now. This is the Mid-Atlantic Ridge. Figuring this out will help solve the puzzle of our planet's creation. I can tell right now just by looking at that. First, I'm curious, what happens if I take this area and pretend that this area here doesn't exist, and line it up with this area, which looks like has a similar spacing. Okay, as usual, I find my best stuff before I have to leave and do something. And so this video is just going to be rather quick and straight to the point. I've taken the Mariana's Trench here, and well, here I got two different copies of it. One's reversed one isn't. And I just want to show you what is going on here when I line them up. Okay, hold on. Let me see if I get it. See, I'm going to upload this while I leave for work so that you guys can see this. So I hope you don't mind that it's really unedited and all that. But as the Mariana Trench comes in, you can kind of see that how things, you see how that fits right in there, and it shows rotation when you add the two on together, because these are reoccurring patterns, which means that they sat above or below one another. So therefore, that's my whole point of my theory, is that I can show you the creation of the planet by combining two areas together, because they used to sit on top of one another. And you can see how that prediction is fulfilling itself right here when I overlay these two areas. And you can see the spacing of the islands here seems to be related to the features below it, like a comb. And you can see how this lines up here, and it fulfills the images that are below it too. You can see how they play together, right? And then you move it, and you can see how it plays together more, and all, it's just going to do that. You can see the alignments is what gives it validity, because they look how well the alignments are. Okay, they have to be related. So what I'm showing you has to be pretty accurate. Okay, it defies plate tectonics, but that's only because plate tectonics must be wrong. Look how it fits the features right here. Look at that. And anybody can see, you're not crazy if you see this. I mean, this does line up. Anybody can see this. It'd be crazy to say that it doesn't line up, because other people can see it lining up. So you can't be crazy. You know what I mean? Okay, so that's that right there. And you can see, here's the bigger picture. See how it fits? There's a twisting going on, and you can see how the island peaks or whatever, these little bumps fit the features here too, even like that. Yeah. And what you're seeing here is spinning, and like a pizza dough, or you know what I'm saying, like it's drooping and it's being twisted. Now when I reverse it, I get other alignments also that are pretty significant, and they kind of help explain what's going on. See how that fits up? This area reversed to here. So that means that this is unfolded. That this this folds and lines, and these are the same thing here, but reversed. You see what I'm saying? And I can prove that because this area lined up over here so well. It also lines up over here, reversed so well. And if you don't believe me, just stare at this for a while, and you will believe me. You see that? Like that. And then now this is the peak here. This peaks into here. Anyways, this is what I'm going to upload for you guys today, because I have to go to work. And by the time I get back, I'll forget most of this, and I have to relearn it. It's like this every day for me. So you see how it fits? My imagination is not playing a role in this. They either line up or they don't. That's how reality works. It either matches or it doesn't. So there you go. When I get off of work, I'm going to look into this further. Thanks for watching.